Hello, everyone. Please come join us in the Innovation Hub because next up we have somebody that is going to be speaking about air quality monitoring. They're going to talk about Prosense, which was originally developed for NASA to monitor the air quality in the space station. So we're going to welcome Tony Gabriel, who is the VP of Business Development at VOC Instrumentation. Tony has held business development positions in various industries where cutting-edge technology products are created. His latest role has been in the HVAC world, where interest in next-gen products like the air quality device technology is in demand. Please welcome Tony Gabriel.
Thank you very Is it on? No? Thank you. Good day, everyone, and thank you for joining the talk today. Again, my name is Tony Gabriel. The name of our company is VOC Instrumentation, or VOC as it's commonly known. The company has been involved for a very long time in the HVAC industry, and this is our first foray at this show with our products. We had one product in particular that we thought would be of interest for everybody to hear about, and hopefully you'll enjoy the presentation and have a few questions for us. So, when we talk about bringing space technology back to Earth, we're really talking about a product that was developed originally for NASA. So back in 2011, we decided with NASA to test our air quality device on the space station. It actually went up on one of the last space shuttles, the STS-134, in April of 2011, and has been in use on the space station ever since. NASA's goal, obviously, was to make sure to monitor the air quality for the astronauts, because obviously they are in a closed environment up there. There's a lot of lab testing that's going on, so they were a little concerned that certain gases could potentially create some problems for them. So they basically sent the sensor up there, and you'll notice here that we also have the ESA Space Solutions trademark. That's the European Space Agency, and the reason we have that is because the device, the original device, was originally created in Europe, Italy specifically. So this is a picture of astronaut Robert Vittori. He was the one that went up with the space shuttle at that time. And you can see here, he has in his hands this device, which is actually the first working device that we sent up to the space station. I show you this picture because just keep this in mind here as we go through the presentation. You'll notice that the device has changed over time. This actually had 3 sensors in this box, and the 3 sensors, basically each one of them was probably the size of a house brick. So a fairly large device at the time. But as is common with programs with NASA, once they are tested and used in space, the developers or the creators of the device are given an opportunity to commercialize here on Earth. And if you're familiar, obviously, with things that NASA does over the years, a lot of the products that we use today here on Earth were tested up in space at some point in time. And so as of today, one of the 3 devices is still on the space station and is still operational. So that comes to my next point with regards to air quality. Obviously, we've had an opportunity to commercialize this for use on Earth. So you've heard it earlier. I mean, when we talk about air pollution, we're really talking about, indoor air pollution, something that the EPA, for example, does not monitor. They monitor outdoor air pollution, but less so with regards to indoor air pollution. So indoor air pollution is something that obviously is of growing concern. I would say that since the start of COVID, A lot of people have become more aware of their environment, whether it's in an office, whether it's in a home, and so that whole discussion obviously is starting to take traction. So according to research, indoor air quality is 2 to 5 times worse indoors than it is outdoors. And the reality is, I think everybody understands, we spend 90% of our time inside a home, inside an office, or a building of some kind. And so obviously it's important that this air quality be monitored as precisely as possible. Some of the main sources for indoor air quality are very, very different. We're looking at byproducts of combustion, fireplaces, boilers, candles, smoke, cigarette smoke, obviously mold, spores, which is very common. We're looking at cleaning products. Obviously, that's also part and parcel of air quality in a home. Building materials, whether it's paints, adhesives, things of this nature, these are all products that impact air quality to a certain extent, and in a very concentrated manner, they could be obviously a problem for anybody with asthma or allergies. Obviously, there's also pollution coming in from the outdoors, so you have to have a system basically that's able to monitor all these parameters. Just one more note regarding indoor air quality and the problem with indoor air quality. As I mentioned, 90% of our time is spent indoors. 1 in 5 people have issues with asthma and allergies. Actually, 1 out of 8 deaths worldwide is attributed to an air quality problem of some kind. And ultimately, over 50% of diseases, if you will, are aggravated by poor indoor air quality. So there is a problem, and obviously there's a need to monitor the problem and ultimately develop a solution to fix it. Again, when we talk about common causes for poor indoor air quality, we're talking cigarette smoke, combustion, fibers, soil gases like radon, as an example. So there are many, many types of gases that could potentially cause a problem for people. Even that new car smell. I think everybody's familiar with the new car smell. Well, it's actually not very good for you. Those are VOCs, volatile organic compounds, that basically that emanate from the fabrics in a car. And if you look carefully at a new car, after a while you'll see a film start building up on the inside of your windows. So all of these things are very important with regards to monitoring air quality. So what have we done? So since 2011, we've been working on basically taking the concept that we used successfully on the space station, and we basically commercialized it for use here on Earth. Now, obviously, we didn't want to be selling the big bricks that we had sent to the space station back in 2011. So what we did basically is we came up with a product called Prosense. And Prosense basically is a device that monitors a very wide range of airborne contaminants using a patented artificial intelligence and pattern recognition. And I'll talk about that in a second. So we have this device here is no bigger than a wall thermostat today. So it actually is very, very innocuous. You can put it next to a thermostat in your house, in your office, if you will, and it's very, very easy to miss, if you will. So what's different about air gloss? Well, there's a couple of things I think that we need to know. Obviously, we talked about space technology. I think that's a good legacy for the product and the device itself. I mentioned the proprietary technology. We use a sensor array, a MEMS sensor array, using artificial intelligence and pattern recognition. The device monitors real time, 24/7. It's for those who want to use this with an HVAC system. It's connectable via the cloud, via BACnet protocol, via Modbus. So it's very versatile in how it can connect and provide the information. It has a very intuitive interface. So what we've done here is, in order to provide some visibility to the user, we've gone out with the device and actually created a dashboard. A dashboard that is available once the user has installed the device. A dashboard that basically provides a summary of all the parameters that are being monitored in real time. So like everybody else, we have an app for it. It's available on both stores. And you can download the app to your iPhone, your tablet, your laptop, or if you have an application interface that you want to use the device and integrate into your API so that your user only uses one methodology to gather the information, we can help you with that as well. So obviously benefits of IAQ monitoring. You get a complete overview of the indoor environment and any arising issues real time. Like I said, it monitors itself 24/7. Obviously, knowledge of the problem is knowledge is power, right? So knowledge of the problem, the system will provide recommended resolutions as well. And obviously, a lot more people are aware of this. We know, for example, that even people who have been working from home and now are being asked to go back to work because their corporations have these incredibly long and expensive leases that they need to get through, are worried about the environment that they're going back to. And so the building managers of some of these buildings, these office buildings, are actually looking to make changes to be able to alleviate some of these concerns that people have. So how does this work generally? So basically, the sensor captures all of these airborne pollutants that are out there, and then it compares it to a database of pollutants, and there are literally thousands of these. And once it's determined the airborne contaminant and how much of it there is in the air, it pushes this information up to the cloud. And the cloud basically then pushes it back down to your device. So this is a screenshot in time of the dashboard that the device was monitoring. So you can see here, I think in terms of what it can do, its capabilities, with an accuracy that's second to none in the industry. It measures all of these parameters. So it's looking obviously at temperature, humidity, barometric pressure, which are all things that it needs basically to help determine the pollutants. And then it's looking at what we call an overall air quality index, which is basically a summary of the air quality, in the environment that it's measuring. But specifically, it's looking at VOCs. I mentioned that, volatile organic compounds, carbon dioxide. So I think you've probably heard that even carbon dioxide is being used as a proxy for COVID for early monitoring. In this particular case, the device that's pictured here is also measuring carbon monoxide, nitrogen dioxide, and methane. And on top of that, on board, there's also a noise sensor because there is such a thing as noise pollution. And there's also barometric pressure, as I mentioned. So obviously, from that perspective, this device is measuring all this in real time. And I will tell you that all of this has been built in Europe. Nothing is coming from the Far East. So there's a very, very, very strict quality control that's happening at this point. So with that in mind, you can see here on this screen, everything is green. But ultimately, were there to be an issue with regards to air quality, the coding on the circles would change to yellow if you have a problem, a small problem, or red if you had a bigger problem. The interesting thing about this, obviously, is that once these numbers change, you would get a notification on your phone. That sends you a notification in real time that you're having an issue that you may want to look at and see if you need to resolve it. So again, real-time notifications available on your phone. For those who take this kind of system and tie it into a backnet protocol for an existing HVAC system, this can be integrated in that HVAC system as well. So ultimately, with this device, you can probably do some of the best air quality monitoring. Now, we are going to be doing other iterations. I mean, I mentioned before we had carbon monoxide, methane, nitrogen dioxide. We are going to have as well ozone as an option. So our next generation will basically be a plug-and-play device where we're going to have a set parameters of carbon dioxide, VOCs, and then we will give the user the option for other gases like radon, like formaldehyde, depending on what the user actually needs to monitor with the device. So with that said, like I said, we have just come to the show for the first time, and hope if you enjoyed it. If you have any questions, we're actually here in booth number 7049. I'm there with my partner. We can answer any questions. We can get into more technical details about the device and some of the other things that we do with it. All right, thank you.
Does anybody have any questions? Thank you.
Thank you.